Hello, this is the last lesson that we do in this series, and it is focused on technology development and the readiness level of technologies. In this slide I make a description of two main points. I will not read that of course, just highlight that first a bit of a reminder from the previous lessons, 2 lessons ago. Disruptive technologies are those who are typically cheaper, smaller, simpler, and frequently more convenient to use. Therefore, they open new markets and they win against more advanced technologies, simply because they correspond more to what the users want. The second point is that in this context of complexity and fast change, the best thing that you need is to have a system for learning so that you can adapt. A bit the concept of adaptation is related to that. So in this planning you must take a discovery based approach, which means that you must develop plans and tools for learning what needs to be known and what appears to be known tomorrow, next week, next year, and which we may not anticipate today, but which nevertheless will be important. And the bottom line of this is that there are basically 4 criteria that will determine whether your solution will be successful or not, and that is functionality, reliability, convenience, and finally the price, of course. Now let's go with this new slide into a bit of analysis of product development, starting from, of course, science and technology. Now in this diagram I show an analysis made by Goldman Sachs, which is also a forecast about the share of the research and development part in the business of companies, these top 500 companies. So they have the money, they use the money for what, in percentage. Now if you look on each bar, you will see that basically the second from the bottom, the gray one, is R&D, research and development. And you see that there are variations in this percentage in time. For example, during 2003, R&D represented about 16%, very high. Then there were times when it dropped very strongly to about 10%, and then it increases again to 40%, to 15%. Now, you see with red, I show with arrows there. The point is that there seems to be some sort of regularity. When there is less money, the percentage of R&D seems to be higher. Now, there are several reasons for that. Some of the reasons are related to automatic statistics. If the money becomes less in a company and they are cut from different departments and not so much for R&D, so the percentage of R&D goes high. But it's also a matter of investment and priorities in the company. So in time you have periods focus more on investment for growth, and if you look on the bottom I show with the red circles how in certain years the companies are more focused on growth, on developing more capacity, more products, and in some years after that they are focused more on exploitation of what they have. So it's an evolution of cycle of development and exploitation in time. But you see, it's not such a big percentage, 1/3 to 1/10, basically. But it's a lot of money for the companies, and the question is why. Now, this is the product life cycle. First, you have on the bottom in this slide R&D. So basically you put money into it, you don't gain from it. it's an investment. And then after a while, the cycle goes on the positive domain, and it's the life period of that product, is the maturity of that product, which is exploited by the company. Now, this product might disappear completely in time or might be recycled, and depending on that, you'll see the trajectory having some variations. But the point is, R&D is in the minus with money, then exploitation is in the plus, of course. But the question is, how much is this related to science in universities? Because I'm sure many of you may say, like many researchers that don't have much or focus in business, they say, okay, we do the research, the discovery, the real stuff, and others, the companies, are exploiting it. So this is their philosophy, and many people believe it, especially researchers. Things are not like that. In fact, you have discovered some technologies, some scientific principles, and so on, but from there to creating a product that actually serves some needs of the people so that it can be used on the market, it's a long way, and it's a lot of investment, and roughly it's about 10 times more money that is spent actually for the development of the products that are developed based on some scientific and technological research in public institutions. So it's not that for nothing, it's 10 times more. People don't know that usually, but this is why it's not so easy to make a product. Here in this slide, I show a bit the phases, 4 major phases. And if you look on the left, you see that the curiosity-driven research, which is university research, science and technology, it starts there on the left. After that, you have a product idea, starts with that, and then a solution proposal, and then develop a prototype, and then first tests with the first version of the product, and then commercial product service. That is the one that you can put already on the market after you tested it. So you see the pre-commercialization and commercialization stages with different phases in it. These ones take a lot of investment. Now, if we make a step back to understand a bit the perspective, let's see what happens when you have a product. Roughly, let's say you have a first version, you have it on the market, you will develop it more in the future, but it works. So you want to expand on the market. What happens? Well, there is a pattern, and it has exactly this shape, which is called the Gartner's hype curve, which means that when you have a new discovery and it becomes well known to the people, you have first a big hype, meaning high expectations. Really, everybody thinks that this is going to revolutionize the world and so on. So this peak, you see it here in this diagram. However, soon after that, your press becomes less favorable, a lot of disappointments, it doesn't work like we thought, and so on. And you go into a through of disillusionment, or let's say a hole of desperation. Some people call it like that. And actually, this part corresponds to the valley of death in the financial theory of research and development that we discussed in earlier lessons. This is where the difficulties are the highest in terms of technology, or for a technology, or for a company, for a startup, or for a project that is developed. And only that, there is a period of adaptation. Actually, really this word, it is used in describing this pattern. The original idea and the project and the technology is actually adapted so that it corresponds more to the reality and less to the illusions that you have and expectations that you have at the beginning. And then you have a next curve that is going up, but not as much as the first expectations. They're more realistic. But this is how your technology and product actually becomes more mature on the market and functional on the market. And this is called the slope of enlightenment, and then the plateau of productivity. You see it yourself on the diagram. Next question that you may ask, I address in this slide, and that is how a new innovation is spreading across the society and on the market in economic terms. Here also there is a pattern, and in blue, this is the main pattern. In blue there is a curve like that, bell-shaped curve, and on the curve you have several categories of consumers, or people if you want, groups, depending on their behavior. The first is called innovators. These are really the first ones that jump to adopt this innovation. They tend to be loving innovation, so they are the first that adopt those. Technology geeks, novelty fans, and so on. And then you have the category of early adopters. Not so geek, but basically eager to be modern and to develop new things. Together these two categories make up about 15 or 16%. Then you have a shift into the bulk of the population. The next category is called the early majority, which is about 1/3, 34-35%. And then you are in the middle. At this point, the, let's say, most innovative half, or novelty-seeking half of the population, you have it, and the rest will come a bit automatically, to simplify. You have the late majority that will just do what others did, like they don't like to be left behind, so they will also adopt this innovation. And then at the end you have the laggards, the last ones that basically either don't have the motivation or no reason to adopt. They may adopt it or not. So this is how an innovation spreads. Now, in terms of what this means on the market and saturation, with this second pattern, the yellow line, which is an S-curve, you see how the market saturates with this product. If you remember from the previous lessons, we used this S-shaped curve to describe how the technology develops on the market. So these are the two patterns overlapped, basically, meaning that at the end, when you also got your late majority and the laggards, also your product is saturated on the market.